Hey guys, today we're going to work between converting function equations to tables. A function equation is just like a y equals mx plus b equation, except here, instead of y, you see this f of x. That just means a function of x. In 8th grade math, you're going to get into more about what functions are specifically, but for now, don't let that freak you out. You can basically pretend like f of x is the same as y equals 2x plus 3. The function of x equals 2x plus 3 is the same as y equals 2x plus 3. Don't let that freak you out. Okay, so here's the deal. If I want to turn the function of x is 2x plus 3 into a table, then over here I'm going to have x, and over here, instead of writing y, it's just f of x, function of x. But again, don't let that freak you out, it just means y. Let me show you how we would go about doing this. To figure out the function of x equals 2x plus 3 and turn it into a table, let's just use some pretty easy numbers, 0, 1, 2. I want to complete the table for my function of x values, so these guys over here. What we're going to do is pull out our equation, and instead of x, we're going to write a pocket. So we have 2 pocket plus 3. This 2 is squished next to the pocket, which means we're multiplying. Then what I'm going to do is I'm going to take out my first x value, in this case it's 0, and plug it in to the pocket. So instead of just having a blank space, I'm going to put in 0. And now I'm going to solve out this expression. 2 times 0 is 0, plus 3, 0 plus 3 equals 3. So what that means is when x is 0, the function of x, which again, don't freak out, it's just like y, the function of x equals 3. So I'm going to put that number in my table. Then, to figure out what the function of x is when x is 1, I'm going to pull that 1 out of my table and plug it into the same expression, 2 pocket plus 3. All I'm doing is replacing this x with a pocket and then plugging in values. So 2 times 1 plus 3. 2 times 1 is 2 plus 3. 2 plus 3 is 5. So when x was 1, function of x is 5. And I'm going to put that right in my table. Let's go ahead and do the last one. I bet that you're catching on to the pattern at this point. Let's do one more. So 2 pocket plus 3. This doesn't change. The only thing that changes is what I put in my pocket. And in this case, I'm going to put my 2 into the pocket. And solve it out. 2 times 2 is 4, plus 3. 4 plus 3 is 7. So when x is 2, the function of x equals 7. That's it. Let's do another one. The function of x equals x minus 4. The function of x equals x minus 4. Let's make another table. So I've got x on this side, and on this side I've got the function of x, which again, x just like y. Let's throw some negatives in there. Negative 1, 0, 1. So I have my x values, and what I want to do is figure out the function of x values by turning x into a pocket. So in this case, I'm going to write pocket minus 4. That's the expression I'm using. And now to figure out what the function of x is, I want to go ahead and take my x values from the table and plug them into my expression where x used to be. So in this case, negative 1 minus 4. You should remember when you subtract with negatives, you use keep, change, change. So I have negative 1 plus negative 4, which is negative 5. So when x was negative 1, the function of x was negative 5. Let's do another one. Okay, so we've got pocket minus 4, and this time the x value that I'm plugging in is 0. So let's go ahead and do that. 0 minus 4. You have no money, you spend $4, now you owe the bank 4. So this is negative 4. When x was 0, the function of x was negative 4. Let's do one more, then it's going to be your turn to practice. If it seems easy, I'm glad. This time, I lost my pen. This time, I'm going to take 1 and plug it in to my pocket. 1 minus 4. You have $1, you spend 4, keep change. Change. 1 plus negative 4 is negative 3. So when x was 1, the function of x was negative 3. I think you got it. Your turn to practice.